This video covers potential outcomes. At the end of this video, you should be able to use a potential outcomes framework to describe an analysis of a treatment effect, use the differences estimator to estimate the effect of a treatment, and explain the benefits of randomizing the treatment when estimating its effect. Let's start with a motivating question. What is the effect of online classes compared to in-person classes on exam scores? When we ask this question, we're really asking when you are enrolled in an online class, so for example, watching this video now, how well are you going to do on exams as compared to how well you would have done if you had instead attended an in-person class? So one way you might think to estimate the effect of online classes is to collect data from different individuals. So in this regression, I represents an individual. And we could collect information on their scores, exam scores, and we could also collect information on whether the individual was in an online class. And so you can imagine that this online variable is a dummy variable, so it's equal to 1 if the class was online and 0 otherwise. And one question we might ask is whether beta 1 hat, the estimate of the online coefficient, represents the effect of online classes. I think we'll see shortly that the answer is it depends. It depends on how the data were collected. So for example, you might wonder if we were to simply survey different instructors on whether they decided to use an online class or not, and then we looked at the scores in those online classes versus the scores in in-person classes, perhaps that would tell us the impact of online classes on test scores, but perhaps there are some omitted variables there. We'd have to wonder what else might be different about those classes that were online versus in person. To further dig into this, we're going to use a framework that's called potential outcomes. So we say that an individual I can either participate in a program or not participate. So in the example we just talked about, we would say that xi equals 1. Think of xi as like a treatment indicator. So xi equals 1 if an individual was part of an online class. Xi equals 0 would be true if the individual was part of an in-person class. You could also imagine applying this framework to something like a drug trial. So xi equals 1 if an individual is taking an experimental drug, xi equals 0 if they are not taking that drug, or perhaps they're taking a placebo instead. Now, we also say that each individual has 2 potential outcomes. The potential outcomes we denote as yi parentheses 1 and yi parentheses 0. And we have to imagine that in either case, if the individual had participated in this program, then the outcome that they would realize is yi1. If the individual had not participated in the program, then their outcome is yi0. Now, one thing to note is that in practice, we should only be able to observe one of these 2 potential outcomes for a given individual. And so one way to think about this distinction, I'll make a table here. There are 2 potential treatment statuses, if you will. So an individual could either be in a control group, meaning that they are not participating in a program, or they could be in the treatment group, meaning they are participating in that program. But each of these individuals, one who's participating in control and one who's participating in the treatment, still have these 2 potential outcomes. Okay. So for an individual who is in the control group, we should be able to observe their outcomes. So for example, if an individual is in an in-person class, they are not in an online class, so they're effectively in the control group. And we would observe this this outcome, this potential outcome, their test had they not participated in the online class. Now, in principle, we could ask the question, well, how well would they have done had they participated in an online class instead? Now, we're never really going to know that, but you could imagine that potential outcome. We can still ask the question in this thought experiment, how well would they have done had they instead participated in an online class? Similarly, if we look at an individual in the treatment group, namely they are in an online class, then we're going to observe a grade for them, and that grade is their potential outcome had they participated. And once again, we could still hypothetically ask this question for this bottom left cell, how well would that individual who took the online class have done on their exam had they instead taken an in-person class? Okay, so again, even though we don't observe all four parts of this table, the idea of potential outcomes could help us to think about measuring the impact of a program, even though we don't have all the information that we need. So to think through how this might help us understand measuring the impact of a program, let's look at some hypothetical data. Now you can tell these data are hypothetical because I'm actually giving you both a potential outcome for, both potential outcomes for a number of hypothetical students taking these four different classes. So again, normally we would not be able to observe both potential outcomes. So I'd like to use the information in this table to ask what is the average effect of online classes? And then in a moment, I want to think about which of the following outcomes we will actually observe. Okay, so when we ask the average effect of online classes, we are really asking how well are students doing in an online class compared to how they would have done had they taken an in-person class. So if we have all this information, it should actually be relatively easy to do that. So you'll notice that that question I just asked is essentially the potential outcome for if they are in that online class compared to that potential outcome if they are in an in-person class. And given all this information, we could simply find these differences. It looks like the difference is either 2 points or 3 points. And so if we wanted an average effect, we could simply average those numbers and say that the mean effect is 2.5. Okay, so given these potential outcomes, we could say that the average effect of taking an online class as compared to an in-person class is an increase in scores of 2.5. Now, of course, we're not going to observe all these. So what we'd have to do is ask which of these students were taking an online class and which of these students were taking an in-person class. So let's suppose for a moment that econometrics and statistics were offered online and intro econ and chemistry were offered in person. Okay, so if econometrics and statistics were offered online, then we are going to observe these two numbers. We're going to observe the grades of students in those classes, and those should match the potential outcomes of the students had they taken the online class, which of course they did, but we're not going to know their potential outcomes had they taken the in-person class. So again, we could ask that question, how well would they have done, but in practice, we're never going to know how well they would have done because they didn't take that class. Similarly, for students in the intro econ and chemistry classes, we are going to observe their potential outcomes had they taken the in-person class, which they did, and we could imagine asking how well would they have done had they taken an online class, but we're never going to know that. So once again, we don't know those potential outcomes. So we might wonder, how do we actually estimate the impact of an online class if we didn't have all this information that we use to calculate the mean of 2.5? And one perhaps logical approach is to use what's called the differences estimator. So in the differences estimator, we're going to ask, what is the expected value or the average of the outcome y, given that xi equals 1. In other words, given that the individual was in the treatment group. Then we're going to subtract that, the same expected value, conditional on the individual being in the control group. Okay, and so you can see that fairly easily here. This first expected value is going to be the average of these two numbers, 80 and 84. And so that average should be an 82. Looking at this second expected value, we're going to ask, among all those who were in the control group and the in-person classes, what is their average? And so the average of 83 and 89 is 86. Now, one thing you'll notice is that that difference, 82 minus 86, is equal to -4. So we're finding that the average scores in those who took online classes is 4 points lower than the average scores of those in in-person classes. So notice that this seems to contradict the conclusion we came to earlier, that there was a positive average effect of online classes. And so this is a situation where we'll have to think about why might this be? So is there some reason why these two things don't match? And we should keep in mind that there may be other differences in these classes. So perhaps there's something about econometrics and statistics that is different from intro econ and chemistry. Perhaps they're more difficult classes. Perhaps grades tend to be lower in general. And so perhaps this comparison is less than ideal. So again, we'd really like to be able to measure what we did in this column on the right here, measuring how well each student did relative to how well they would have done in the opposite treatment. Whereas in practice, we're stuck measuring something like the differences estimator. So we've just highlighted a number of concerns about the differences estimator, in particular when we use observational data. And when I say observational data, I mean that we are simply going to some situation that's already happened and we're collecting data on that. However, there are some situations where the differences estimator is actually quite useful. In particular, when we have a randomized experiment, that differences estimator we'll see shortly is going to be much more effective. So suppose that either in this online class example or the experimental drug example, that each individual is randomly assigned to either the control group xi equals 0 or the treatment group xi equals 1. Let's think for a minute about why the differences estimator may be a better estimate of the impact of the treatment of the program participation in this case. So first, think about who we're going to be measuring in this group. So when we measure the average outcome of those who are in the treatment group, remember that if the individuals were randomly assigned to the treatment group, then the average outcome for those individuals is probably a pretty good estimate of the average of all potential outcomes within that treatment group. In other words, since we have randomly selected a number of individuals from the sample and we've assigned them to treatment, we're probably getting a good unbiased estimate of the average of the potential outcomes of all individuals had they participated in treatment. Similarly, since the control group is randomly assigned, we're probably going to get a good estimate of the average of the potential outcomes of yi0. In other words, we'd like to know what would have been the average outcome of all individuals had they not participated in the program. This second part of the differences estimator is probably going to be an unbiased estimate of that average, again, because those individuals were randomly assigned. This is very different from the situation that we talked about before in observational data, when those who participated in the treatment, those who were on online classes, for example, may have been different in other ways from those in the control group, namely those who participated in in-person classes. But when we have a random assignment, then we should expect that we're getting unbiased estimates of the averages of the respective potential outcomes for the population. And that's why we should get a good estimate of the impact of that program. Another way to think about this is that we're getting a good estimate of the counterfactual. So even though we're still only observing one potential outcome or the other for a given individual, by randomly assigning, we're more confident that these two differences, the differences in these two expected values, are giving us a good sense of how well the population, the entire sample would have done in each of these situations, either in treatment or in control. So you might wonder, why are we using this complex notation? It sounds like a rather simple point that random assignment produces these unbiased estimates of a program's effect. But I hope that one thing you can take away from this is that the counterfactual is important. This idea that every individual has two potential outcomes, and we unfortunately in the real world only observe one of those. So just to see how this is sometimes used in the real world, here are two parallel examples. They may suit a variety of political views. These are two quotes describing how the policies of the US president may have impacted economic conditions. So the first quote comes from the chief economic advisor under President Obama. He said in 2014, America's businesses extend the longest streak of private sector job gains on record. The data underscore that 6 years after the Great Recession, thanks to the hard work of the American people and in part due to the policies the president has pursued, our economy has bounced back more strongly than most others around the world. In 2018, President Trump said jobs, jobs, jobs. Unemployment claims have fallen to a 45-year low. Together, we are making the economy great again. And so feel free to focus on one of these or the other, depending on your political leanings. But in either case, both of these are essentially making a claim that the president's policies improve the economy in some way or another. And so we might ask this question, what is the impact of the president's policies on economic conditions? And so we might think about, well, what is the potential economic outcome? So Y is, choose some economic outcome of your choice. What we'd really like to know is what are the economic outcomes in a world where one, the president's policies were implemented versus the economic outcomes of the US in a world where those policies had not been implemented. So this is what we'd really like to know. How does the current state of the economy compare to the counterfactual world where those policies had not been implemented? But if you think about what each of these quotes is saying, it's essentially saying that economic conditions at this particular point in time are better than economic conditions at some previous point in time when those policies had not been implemented. So in other words, we're effectively measuring the distance the differences estimator. So each of these quotes is essentially saying, well, take a look at how economic conditions are at this current point in time when the president's policies are being implemented, have been implemented, and compare that to the economic policy or the economic conditions compared to several years ago, in which case the president's policies have not been implemented. We may see a positive number here. We may see some improvement in economic outcomes, but unfortunately that doesn't mean necessarily that this difference can be attributed to the president's policies, because we really have to ask this question: how well is the economy doing now as compared to how well it would have done absent the president's policies. And of course, this question is impossible to answer. And in fact, many economists have speculated that the president may have much less effect on the economy than popular opinion suggests. But again, this is unfortunately very difficult to know for sure.